Hello, everyone. This is etcd robustness test meeting. Today we have August 28th, and let's try some issues in that happened since then. Let me share the dash or the document. As always, if you have any questions, please feel free to ask. This is like or this area requires a lot of domain knowledge. It's not very easy for to learn. So if you need any help, I'm happy to answer any questions. But if there are none, then let's move to the next things. Just check. Can you hear me? Is everything okay on my side?
Yes, everything is okay.
Thanks. So I don't think there were any new issues reported for the robustness testing. Last one is from the last month. I think there is some discussion about Jepson report, which is in the same area. Let me just quickly show it. Yeah, so there was one update by Benjamin. I think and there was some blog post by Jepson around a couple of issues because we found one of the issues with the Java library. So if you're using Java library, or at least there is a client side correctness issue, or I know it's called serial, like client side issue with serializability, which I think it mostly depends on, the impact of it mostly depends whether you care about exact revision numbers and block they're progressing one by one. Sequential. Where is try to find it this way. Yeah, this is the one. So this is maybe I will label it. Yeah, this is the issue that if the way that Java and Golang client retries could be problematic for in some situations, or I would say only in some, but depending on how correct you want to be, client can break serializable. The high level, it's just a problem of retries being or etcd retrying transactions, which can have a side effect, and retries being based on error. Sometimes error can be a network error, and it can happen only on the client side. So client can send a request or transaction to the storage, but get returned an error and try to retry, even though the transaction was persisted. So if the transaction is put, client can by mistake, instead of putting once, can put multiple times and not observe that it put multiple times. From client perspective, or from application designer perspective, this is only a problem if you care about exactly revision increasing exactly by one, and knowing exactly how knowing this exactly. I don't think it matters in most cases, or I think it's not as impactful. Like, for example, for Kubernetes uses optimistic concurrency, which means it does a conditional transaction. So if there are two transactions uh, sent, or there is a transaction that is retried and succeeded, it will always fail the second transaction. So we cannot like do retries will not result in two transactions being executed on etcd, because second one, if the first one succeeds, the second one will fail because the condition will fail. So for Kubernetes point of view, it's not an issue, but still, like, there is some push to look into this and fix, because I think we should strive to be as correct as possible. Yeah, so this is like two issues that might be interesting if you're looking at the robustness or correctness of etcd. Let's look at the prow. Oh, that's not good. Yeah. So since some changes, or from, I know, 2 weeks ago, or I think maybe 4 weeks, it's been much better. We now have, I would say is pretty stable robustness testing. Which overall, the goal for me, the goal is to be able to spend to time box and spend only hour or half an hour on triaging the issues and not being overwhelmed. But still, let's look at the maybe recent failures, with which looks like there was a lot of failures in the last two tests. So taking the first one. Okay, so we have a link if you want to follow. So I have one failed test, and it failed because of minimal QPS, which is not great. I think if you're not following all the our previous meetings, the since introduction, or minimal QPS comes from idea of needing to, or wanting to, or validation of correctness being based on history of operations, but not really knowing how many operations are there. So we want to guarantee that there are at least, I don't know, couple hundreds of operations that we validate, and there is enough QPS that we can create a high probability of races, or concurrent requests and traces between those requests. However, since we introduced compaction is much heavier operation that runs in background, and this create much more load on etcd, and apparently we are having problems hitting our previous goals of QPS. I think it's worth to note those issues with QPS and keep track of them, and if we have enough, like, either make a decision whether we want to lower our goals, or if there's or collect ideas what we can do to improve it. I think it's been repeating for a couple of meetings that we have this, like, even a couple of times before. So I think we should slowly think about investing there. And the second failure from the day before, no, this is from yesterday. So the first failure was from today, second one will be from yesterday. This is a lot of failures. It's first time I have seen so many failures. But so let's dig down. Ooh. Oh, so looks like we were not able to even hit 100 QPS in one scenario and consistently. So looks like we lost the silicon lottery, and the job was scheduled on some overloaded machine, and we didn't get enough resources to to execute the test. So it's same case of QPS, 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 QPS. Yes. I mean, it's both good and bad. This is a error in the test. So this is like our goal to have this level of QPS. And we can try to mitigate, for example, by increasing just the machines or requesting bigger machines, which means at least the etcd is correct in those scenarios, and we don't see any other issues. Yeah. Which is better. Okay, I don't know if we will be able to look through it all because it's not very interesting. I hope that if we just maybe check a couple of them, couple more, to not keep you too bored, we will be able to decide. So yeah, also it's important to note most of those tests are failing on lazyFS test. You can recognize it by the name of the test. We annotate lazyFS. And this means that this test, we run a dedicated additional software called lazyFS during the test. And this is a library and a system that we use to validate etcd resiliency to disk failures. And high level, the idea is that we have a user fuse, so user level file system or user file system created on user space running in the user's driver for the file system running in the user space that can simulate failures for us. And unfortunately, this means that there is a lot of CPU overhead, or it creates a lot of CPU overhead to push all the writes through a user space, because now like they go every time there is a write to the disk, it needs to go through the fuse driver and the lazyFS. And this we know from experiments, local experiments, you can clearly find that it uses basically requires additional full core of CPU running just to handle some writes. And for machines with not a lot of footprint or not a lot of like resources, it can overwhelm it. So I would high level group all those failures as lazy issue with lazyFS and minimal QPS. So we basically ran on the node that was overloaded. Yes, Ahmed?
Sorry, I have one question. What was the purpose of introducing QPS at the first time, and why we calculate this calculate this for every scenario?
Yes, it's a very good point. Historically, the first corruption that happened in etcd for 3.5 was a very delicate trace that required two totally independent coroutines to execute at the same point, and when they're executing together at some particular point, both to crash. And this was totally unreproducible until you hit pretty high QPS. The goal, like even the QPS back then, it was much higher. The QPS then, I think I needed to. I was working on the issue myself, and it took me a long time to reproduce it. And after only the contributor that reported the issue said exactly like described their environment, and it basically required me to run over I think 1,000 or like a couple thousand of QPS. Which is even much one level of magnitude higher than we now run now. So this example showed that there are issues and correctness issues that require very high, that or that are based on races, which require a lot of things happening within etcd, like a lot of things, transactions interleaving other go routines and reads and transaction compactions in the background, flashing to the disk, everything to be happen all the times, and a lot of things doing. And this can be only achieved with very high QPS. So one of the when looking at the designing the robustness test, one of the principles I wanted to do and to distinguish from the previous framework was strictness. So basically, the framework, the robustness framework, has some set of assumptions that assumes, oh, I can reproduce this issue or all historical issues, and it can reproduce couple of like those issues, sometimes with very low QPS, but sometimes requiring very high QPS. And every time, one of the principles with strictness, I wanted to make sure that if we have such assumption that we need a lot of QPS to find those bugs, we should require it. We should say this. We should, if you would model. I mean, at least I remember, depending on your testing framework, I remember one testing framework that allowed you to have a third state of failure, which is when you think about test failures, at least in Golang, you can either succeed the test or fail the test. But what we would really want is to have a third state which is unknown. We basically, best scenario would be to robustness test to report, I ran the test, I don't know if it worked, I don't think I found an issue, but I cannot give you guarantee that I succeeded. So have a free state logic, which is succeed, fail, or don't know. And I mean, from the high level, the difference would be from the dashboard would be you would not see a red line, you would see, I know, a yellow line, which is I don't know. I think maybe it's supported. Maybe it's supported. It's up to test grid, but that would give you idea of, oh, this is the test that passed. Here are the tests that failed, and here we couldn't test really the quality. The quality of the test didn't allow us to confirm whether we succeeded or not. So that would require us to have a free state result. But because Golang itself doesn't allow us to have a partial failures for the test, we are just failing and saying, this test didn't do what it's supposed to do. It didn't get the QPS required to reproduce important correctness issues. So we say we failed. So that we can. It's a signal to maintainers that, oh, we should either tune this test to not report as false positives by marking it, or like I said, lowering the requirements, which is not great if we keep lowering requirements every time, but sometimes you cannot do it otherwise. Other way will be request higher machines. And my high level suggestion for this issue would be to create an action item to request higher machine size or bigger disk for that would be, I mean, bigger disk maybe in the lazyFS case not, but high level bigger disk should help, or let's say faster, more IOPS. So bigger disk on cloud. So on clouds, if you run on cloud, the IOPS, disk IOPS are one-to-one related to disk. How much you disk request, you get higher IOPS because you share IOPS with all other tenants running on the same disks. So if you're smaller, you get very small IOPS output. I think you write this is how do you write IOPS? I don't remember. So we would need to request it. In here, maybe we would need more CPU, higher or request more CPU for lazyFS, or this is my assumption because like only lazyFS failed. And in previous case, I would say for compaction, one of the things that would help most, I think, is the IOPS. Yeah, so if anyone is interested I know I can and want to contribute maybe something easy. I hope that I know the Kubernetes infra folks will not get angry about us asking us for asking for more resources, but if someone wants to contribute that, it would be great. I can give you some breadcrumbs. So if you go to Kubernetes test infra, some blog. Jobs. Where let's see. Test infra. Oh, I'm running on some. I'm not running on master, so maybe it was not there. Yes, we have etcd. Awesome. So there are periodics. So in the periodics, we request 4 CPUs. Oh, that's maybe on some. Oh, this is end-to-end test. This is end-to-end test. This is unit test. This is robustness tests. Oh, 7 cores. Oh, not great. Yeah, so that task might be harder than we thought. Possibly we should, because 7, I don't know if it's memory, because it's hard to know if we run out of memory. I mean, those tests don't produce as much data, so they don't allocate enough. But for CPU, so I don't think we are hitting like high memory to be throttled on garbage collection. But for CPU, we should be. That's a lot of CPU, I think. So yeah, Ahmed.
Can we ask about our usages from infra folks, or is that not possible?
That would be a very good way. Yes, that would be a very good suggestion to get the current usages. And historically, we had reports from it when we run. One of the benefits, maybe only benefit of running GitHub on GitHub Infra was that we had reports for resource. There was a ready plugin to get resource usage for jobs running or GitHub Actions running. Yeah. Oh, there's still some interesting PR from 3 months. We no longer report. So yeah, there is no longer reports because there is limited data size. So it's been, I think it was cleared up. But some tests, though, if you went into some of the tests when we were suspecting that there is not enough resources, you would get. There was a dedicated GitHub action, I know, plugin that would give you reports on the action, how much resources you used, what was the minimal or what was the average usage of CPU, maximal usage of CPU, and all those interesting things. I don't know how to get it on Pro, but that's also a very good thing that we could follow up is ask how. So we get 7 CPU. That should be enough. So maybe other action item would be get CPU memory disk usage stats from Pro from infra. Yeah, so we can decide whether we should increase it or not. Yeah, so I think that would be the next good step. Thanks for Ahmad for suggesting it. It's been on my mind, but I think that would be a good next step. So yeah, if you're not sure, you could, I think, on Slack, maybe reach out to test infra, like asking. I mean, it should be very easy, so I can take a look if no one is interested. It should be based just on, hey, we had this job failed, looks like CPU throttled issue. Can we see any CPU stats from the job, or how we can add those stats? Okay. So I wrote action items. If no one is interested, I will try to take care of them. Just thinking, should we look further back in the history? We have a failure here, and here, and that's all of them for here. Okay, here we have member replace. There has been problems with member replace fail points. That's not great. So member replace is very complicated test, or maybe unique test. Because the goal is to member replace is a fail point that is meant to simulate a situation where administrator would do a disaster recovery. So I wanted to test administrative operations, because one of the goals of robustness test is let's look at what are if can etcd maintain correctness under any situation, and so I created a list of what are from most probable to the least probable situations are, aside of so the most popular would be normal operations, like I know serving just load and nothing is happening, which is like standard, and the least probable would be disk corruption, memory corruption, and all those things that you could hit pretty rarely, and maybe we don't need currently to test it, or even etcd doesn't really protect you from memory corruption. If you have faulty hardware, etcd will, I think it will detect it and report it, but it will be able, it can serve a lot of requests still while being corrupted and not notice it itself. But I've seen, from my personal experience, I have seen those level, a lot of, I have seen multiple memory level corruptions, and I can say with newer Golang versions, it works much better. So Golang is much safer for the memory corruptions, because I've seen a lot of broken stacks in at huge scale. You get a lot of issues with this, but recent newer Golang versions handle it much better. but still, you can go from the top from the most popular to the bottom least popular. And one of the middle is, or pretty early on top, will be administrative operations. And one of maybe much more rare administrative operations would be operation done in case of corruption happening, and or whatever decision, administrator making a decision to, oh, this member is bad, I need to purge it. So basically taking an etcd or deleting its disk, or maybe just administrator losing the disk that was under the member. Maybe that's an idea for a separate test. Yeah. So what happens if there is member with no disk? Can the cluster recover? Cluster will recover, but will etcd behave correct on every request? Because like high level, the goal is, it's not about, oh, we are correct most of the time. The goal is to be correct all of the time, because I know if you're a database, you're the last place that people will look if there is a bug or strange behavior. Database or key value store like etcd is the last place people should look for if there is a corruption or like strange things, because we need to be the most solid foundation for people to build things. Yeah, so I don't think I will have time to dig into this, because it's usually pretty complicated. I haven't even had problems with debugging this because it's very complicated, and it has sometimes Raft is misbehaving, or basically etcd is failing to recover from it, which is good and bad, because at least we don't there is no corruption, but the cluster doesn't recover, which is also not great. So I'm trying to I would need to try to understand from bug perspective why we sometimes don't recover from this, and that would be a bigger issue. It's not correctness issue, but reliability issue from etcd perspective. Going to the next failures, we have two minimal QPS broken, and a one minimal QPS broken. Okay. So maybe let me move this from investigation to discuss or identify and discuss improvements. So yeah, so we can collect those lower and keep them separate. Here's the test that I was looking into, and the last test in this row is has a lot of logs. Minimal QPS. Yeah, there is a lot of logs because it was black hole member revision, black hole member fail point. Oh yeah, because we do a fail point that requires disconnecting two members, because it requires sending snapshot from one member to another. So we basically need to cut connection between them. So there is black holing and a lot of other failures. So let me copy this. Yeah, so great. We've done one dashboard. That's the furthest we have gone in this meeting. We have finished full dashboards. I can quickly looking through. Maybe we have IMD, ARM. ARM looks great. Whoa, that's awesome. Better than I was expecting. That's surprising, because usually ARM has performance issues, or historically ARM had performance issues on GitHub. Now it's green, which I no longer can complain about ARM. And 3.5 looks great. Like, what is going on? Maybe maybe there is a performance regression in 3.6 because there is one failure in 3.5 and there's so many performance issues in 3.6. I need to talk to James about performance. Okay, there is some bad things with 3.4 because definitely 3.4 maybe has also TPS issues, but that's. And 3.4 on ARM. Oh yeah, okay. So ARM has one issue. Yeah, I mean, it's great that we can look through. There is not enough them, so at least we can see. Okay, that's a first long time I have seen this. Huh. That's. I haven't seen this back or this report for a very long time. Member exited, fail point, waiting for my member to exit, server exited, starting server is panic, so member was restarted after panic. No key operations for client. Oh no, that's a good. I mean, that's not a problem. I was just okay. Still very suspicious. The suspicious part is this. I mean, maybe I should allow this, but okay. This is one of the validation, another strictness validation. Which is, I didn't thought that it would ever happen. Or those are two requests. So in the robustness test, one of the things that is done is we do validation for watch, and I mean also also validating that model works and that or etcd behaves up to a model, and watch requires etcd to go through revision from each revision one by one, so consecutively, and only increase it by one. And this means that we make sure that it happens because we want to make sure that etcd moves increases the revision when it should and doesn't increase when it shouldn't. The problem is that to guarantee that, we cannot allow any other requests that we haven't seen, any other request, like the test should take full history of everything is happening at CD, so be like take ownership. But and to make sure that I know someone doesn't run validation, sometimes someone doesn't run validation on incorrect history, or sometimes I made mistaken merge two histories by mistake, which returned different results. To make sure that we test exactly what we think we are testing at the beginning of the validation, I make sure that I make one request to etcd at the beginning of the test and at the end of the test, and I assume that those two tests succeed and those two tests are persisted, so I can assume that the test starts from this revision and ends on the second revision, and ends on some revision. And if this is broken, the test fails. And this is the example of this, that the traffic sends first operation and it says it failed. And the fact that a validation requires first request to succeed. And it totally later failed that broken validation required non-empty database. So to guarantee that the database is empty at the beginning, we make a first request that validate, like that needs to succeed, to double check that the validation is. And also that you can, one thing you can see, I'm using to validate watch, I'm using the last operation, and to make sure that watch has gone through and noticed all the latest revision. And if I broke the first operation, the last operation also breaks, because I don't send any operation with max revision. So no requests were sent, and so everything failed, which is very strange, high level, because it means for some reason etcd didn't accept the first request. It was not healthy during the first request. That would be my high level assumption. So I mean, when you run the test millions of times, sometimes you will even hit the hardware corruption level. And maybe we hit something, because here it looks like a panic. Oh, what? Okay, this is interesting. So here we start at the process. It runs, runs, does some things, nothing interesting, became candidates and stuff. And we start second server, and it crashes. And it panics. No, oh no, this is fail point. No, okay, so I was wrong. So this is a fail point. So okay, so this is, it panics after creating a fail point. So for some reason, when we started sending requests to etcd, the first request didn't succeed. Oh, and I wrote those three evaluations in the broken thing. I think the action item would be make sure that I don't know why. The first request, I don't know. Maybe let's wait until we have enough failures to invest in time, because high level we have health checking, and the only thing we could double check is our health checks doing what they're supposed to do. So to explain it before we start put any load, or when we test etcd in any end-to-end test, we make sure that the cluster is healthy and it's proceed it's the health checks are passing before we finish even the function for start cluster, which means there was a request that failed. So maybe I'm not, maybe it would be double check this, double check that we have check etcd before before I think I remember that the end-to-end tests depend on a log in etcd. So they wait for a log, specific log. I think it's ready to start serving traffic. And apparently it means that 1 per million cases, this log is not enough to say etcd is ready to serve traffic. Yeah. Another, we have member. Oh yeah, so in the second next failed test, we have a case where member replace restored cluster, but in a way that it didn't generate the log line. So here is the log line that when you start etcd in end-to-end test, it basically waits until etcd reports, I'm ready to serve traffic, to serve client requests. And then we say, oh, it's ready, we can start testing it. So apparently, or in this case, the issue was that etcd never recovered it. So member replaced cluster with member cluster or file point or etcd never recovered from. So this is another bug in the member replace. I introduced this file point to make sure that we cover it, but if it looks like it's very flaky. Okay. Here is max QPS. Oof. And again, max QPS. If there are no max QPS, I will stop noting them because it's not very interesting. And you have member replace, but here member replaced work, but max QPS didn't hit. Yeah, max QPS. And here, okay, no lazy FS. Oh, and this is like, we wanted to hit 200 QPS and we only had 86. This is a huge variance. Like basically on some of the runs, we had got half of the CPU that we wanted. Like, or at least from other tests, we only got half of the CPU. So this is like silicon lottery, or I'm calling it, comparing to, I know, buying a CPU or processor, but and getting different results based on quality of the silicon that you happen to buy. But here we basically, when running a test, we are also randomizing which server and rack and VM that we are running on. Sometimes you also get unlucky. And here is the more complicated, and here is member replace. So we should consider changing member replace. But with that, we went through all the robustness tests. Debugging, moving. That's the. I mean, it's the first time we managed to get through all the bugs. So that's a very good trend. And there are two more tabs, but there are pull requests. I think we should separate them because pull requests are not very useful to investigate, and because they mostly depend on contributor not making a mistake, because you can just like fail. But yeah, this means we went through, analyzed all the failures, identified action items, what we can do to improve and reduce the flakiness, and we can, I know, hopefully someone will work on them. If are there any questions? I know asks. Is there anything blocking you for, I know, taking one of the action items, or is any of them interesting? Let me know. I'm happy to help and guide to do them.
Of course, thank you. I was very busy last week, but I will try to do some of them, maybe.
Okay. Yeah. So if you want to try one of them, feel free to assign yourself or leave a mark that you're interested in doing it. Create an issue link to it, so we can keep track of it. I think that's one of the things, maybe, to create issues for that when we have more, or when I have more idea. But that's it. I think we can finish early. Um, so thank you for attending, and hope you have a great local time.
Thank you. Hope you have a great week.
Yeah,
Goodbye.
you